everyone, welcome to the tutorial. So today we will be understanding linear regression and we will also code a simple stock prediction model using Python and linear regression. So before that, let's have a basic intuition and basic understanding of what actually is linear regression. So if we go by the definition, so linear regression is like drawing a straight line through a bunch of points in such a way that it best represents the trend of those points. So let's consider that we have a few data points. So we have these data points along x-axis and y-axis. So linear regression, what it does is it tries to fit a best line that will try to represent the trend of these points. What this line does here, that it tries to capture the trend that will follow along this line. So if any new data occurs, best fit line can predict the trend of the data. So let's take a simple example. Let's consider that you're a small shop owner and you sell ice creams. So we have your data where you have sales and you have your earnings. So let's say when you sell one ice cream, your earning is 50. When you sell two, your earning is obviously 100. When you sell three, you get 150. When you sell four, you get 200. So we have this basic trend. So now if you see closely, you see a pattern here that every time you make a sale, you earn 50 rupees. Alright, so now looking at this trend, you can cast a formula in your mind. So your formula might go something like this. For your earnings, you will consider your sales. Alright, so we will create a formula for here. Since you're earning 50 rupees per sale, so 50 is constant. And now let's take a particular number. Let's say you go for 5. You, for your fifth sale, you want to calculate this plus 0. Now if you look at this closely, you might see it as a familiar formula, which is y equals to mx plus c, and our 50 is here the m. X is the a variable where the number might vary, and 0 is the constant, and since your starting point is 0, so we have taken it as 0. So now when you put it that way, you will get your answer as 250. So your earning is 250 rupees. So in short, we can say that linear regression helps you make predictions based on past data by drawing a straight line that best represents. So now let's code a simple stock prediction model. Now you don't have to worry, we are not going full Wall Street here. We are keeping it simple, clean, and very Pythonic and very intuitive to understand. So this is our Google Colab. You can go here on collab.research.google.com and you can start writing your Python code there. So let's get into it. For that, we will make our imports of the libraries. So we have imported our libraries, and let's just have a simple walkthrough of why we are importing these libraries. So Panda is for handling the data. Matplotlib is for plotting our data and visualizing how our data looks, or general our predictions. And we have imported linear regression through scikit-learn linear model. And we have also imported train test split, which helps to split our data into training and test set, which we will study about ahead. And we have imported mean squared error and R2 score to calculate the accuracy of our model and the error that might be produced by our model. So we imported via the metrics module of scikit-learn. So now let's go ahead and create a sample stock data. So we don't have real-time stock data right now. So let's create a simple stock data here using Python dictionary. We have our data here, which is in the variable stock data. Now we will convert it into a data frame. So we convert it into a data frame so that we can feed it into the linear regression model. So for that we will use pandas here, simply pd.dataframe, and we will just convert it into a data frame. And to see if it has been converted and see the values, we will use t of dot head, which will represent the top 5 rows of the data. So we have that here. So now let's visualize the data and see how it looks. So this is how our data looks on graph. Now we can see a trend that it is just going upwards, which is very best data to apply a linear regression model over here. So now let's see that and create a linear regression model for this. So for that we will convert our data into different paths, and since we have now our data into df, our data frame, so we will convert it into x and y, which will be further broken into train and testing set. So we just put the day. Let's understand this. So our data is the x-axis and our price is the y-axis. So simply we have just put the our days into x and our price into y. Simple. So now we will convert data into train and test. So why do we do that? So let's assume that you're in an exam and the teacher beforehand gives you the question paper and you can cheat. You can go home, you can study about that. So in that way you won't learn anything. So for the same, we break our data into training and testing so that our model learns from the training set and not from the testing set. So due to which our model gets to test itself and it will actually learn from the training set, and it won't have the time to metaphorically cheat, and it will actually learn from the data. So now we will break down our data into X train and Y train. So we have broken down our data, and for test size we will use 20% of our data, and for training we will use 80% of data. The parameter random state here states that whenever we run this, we always get the same number, the same state in which the data will be divided. So that is why we have set it as 42. It's a convention of setting that. So we have just set that here. And now we will create our model. So our model is linear regression. So we will just call the linear regression class and fit our X train and Y train on the model so that it learns from these training sets of the data. So our model has been trained. So you can see that linear regression has been trained here. So let's test our model and plot the predictions to see how it performs. Let me give you a spoiler alert. It does surprisingly well for such a simple model. Since we do not have a lot of data, it will do well only. So for that we will for predictions we will store it into ypred, and we will let the model predict our x test value. Since we converted into testing set, so we will use this for testing. So it has made the predictions, and let's see now what we have got into ypred. So we have gotten our values here, and if you see, so our x test value has 8 and 1, 9 and 2. So for that we have got our results over here. So these are just the predictions of the days. Alright, and now let's plot it. So this is our stock price prediction for predictions that we have in the testing set, and for plotting you have used xtest and ypred. So xtest is our this data on which we have made the predictions, and since we stored it into ypred, we have used ypred over here to plot it. Alright, so now let's go and let's make it simple, since this is a bit complex to understand. Let's keep it very simple. Let's store a simple future day in a array. So we will predict our sales for day 15, and we will make our predictions. So we will store it in future price and we will let our model predict that. So for we have used a simple string here. So let's just make prediction here. So we have got our prediction is 130 for day 15, which is quite good. So for let's say day 15, our model extends somewhere around here, and this goes like this. So it makes sense that this value increases and this value increases as well. And that's it. You have just predicted a stock price using linear regression in Python. Yeah, it's very simplified and the example is very lame, but the core idea is the same as what's used in finance, health, and even sports analytics. And if you enjoyed this mini project, I guess you would try to implement it on your own, and catch you on the next one. Bye bye.